Hello out there, my name is Olutola, and in this lesson I will continue the multiplication of matrices, which I started in the previous lesson. The link is in the description, and in the previous lesson I did the scalar multiplication, but in this lesson I'm going to work on matrix multiplication. There is a big difference in the way we do both multiplication. So firstly I want to show you what we mean by conformable matrices. So conformable matrices, two matrices are conformable if the number of columns of one is equal to the number of rows of the other. Don't forget that if we have a matrix, let's say we have 1, 2, 3, 4, 5, and 6. This is a 3 by 2 matrix. 3 by 2 matrix. The 3 here stands for the number of rows, and the 2 here stands for the number of columns. So two matrices are conformable if the number of columns of one is equal to the number of rows of the other. Now, for us to do the multiplication of matrices, the matrices must be conformable. It must be conformable. So I want to show you two matrices and what we mean by the conformability of two matrices. Now we have two matrices here. We have A. If A is 4, 2, 3, that's row 1, 1, 8, and negative 5. If A, of course, A is a 2 by 3 matrix because it's having 2 rows and it's having 3 columns. And we have B. B is having 3 rows and 2 columns. So if we do matrix multiplication here, we do AB now. If we do AB now, that means we are multiplying a 2 by 3 matrix. 2 by 3 matrix. We are multiplying it with a 3 by 2 matrix. Now, when we multiply a 2 by 3 matrix, we multiply it by a 3 by 2 matrix, we are going to have a 2 by 2 matrix. Now, if we also do BA, BA is the 3 by 2 matrix. If we multiply it by a 2 by 3 matrix, we are going to have 3 by 3 matrix. When we multiply this with this, they are conformable if the number of rows is equal to the number of columns. In this case, the number of rows is 2, the number of columns is 3. Now, the number of rows is 3 here, the number of columns is 2. So when we multiply matrix A and matrix B together, I see this way. This will go, then we are going to have a 2 by 2 matrix. So what I'm trying to say is that when we multiply 2 by 3 matrix, we multiply it by a 3 by 2 matrix, we are going to have as our answer a 2 by 2 matrix. Similarly, when we do BA, we multiply a 3 by 2 matrix with a 2 by 3 matrix, we are going to have a 3 by 3 matrix as the answer. Now, if these 2, 3, 3, if these 3, 3 are the same, 2, 2 are the same, then we can say that both matrices AB or BA are conformable. That's when we can do a matrix multiplication on it. So perhaps if this is 2, this is 1, that means we can't do a matrix multiplication on it because they don't have the same number of rows to columns. So let's do 1 or 2 examples on matrix multiplication. Or before I do that, I want to show you how to multiply. The way we multiply is very simple. the rows here. If I want to multiply x y now, this row 11 x11 x12 we multiply this column such that we have something like x11 times y11 plus x12 times y21. So when you multiply this row with this column, so that will give us one of the elements, because this is a 2 by 2 matrix. This is also a 2 by 2 matrix, so they are conformable because this 2 here is the same as this. So when we multiply it together, we are going to have a 2 by 2 matrix as the answer, as a result of the multiplication. So when the way we do it, x11 we multiply y11, x12 we multiply y21, then we go again, this row we multiply this column, so we have x21, this we multiply, we go with this, we multiply this, then we add it to the multiplication of this and this. So x21 times y11 plus x22 multiplied by y21. So the same thing we did, we are going to do for this one also. So this row we go, we multiply this column, and this second row we multiply this also. So when we do that, we are going to have x11, that's this, multiplied by this, y12, then plus x12 multiplied by y22, then the second row now, that's x21 multiplied by y12, x21 multiplied by y12 plus x22 multiplied by y. I'm going to do an example on it. I have this question here. The question, so I want to multiply AB. I want to have AB now. I want to multiply matrix A with matrix B. So what I do is to multiply this by this matrix. This row goes with this column. So if I do that, I'm going to have 4 times 1, 4 times 1, then plus 3 times 2. So that will give us 10. That's 4 plus 6. That will give us 10. So I will still multiply this again with this. So that's 4 times 6. 4 times 6 plus 3 times -7. So that will give us 24. This will give us 24 plus minus 21. That's 24 minus 21. That will give us 3. So I will go now. I will multiply the second row here. I'll multiply the second row. I'll multiply it with this first column. So that will be -2 times 1 plus 5 times 2. So that will give us -2 plus 10. -2 plus 10 will give us 8. And we go for the last one now. That will be this second row multiplied by this second column. So that will be -2 times 6, -2 times 6 plus 5 times -7. So that will give us 12, -12 plus -35. and that will give us negative 45. So that's B. That's AB. So if we do BA now, if we do BA, 1 6 to -7 multiplies 4 3 -2 and 5. So if we do this multiplication now, this row goes with this column. So that will be 1 times 4 plus 6 times -2. So that will give us 4 plus -12. 4 plus -12 will give us -8. So I'll go again. This row multiplies this column. This row multiplies this column. That will give us this slot here. So we are going to have 1 times 3 plus 6 times 5. So that's 3. This is 3 plus 30. 3 plus 30 will give us 33. Then we have this row now. This row multiplies this first column here. So that's 2 times 4. 2 times 4 plus -7 times -2. So if we do that, we are going to have 8 plus 14. 8 plus 14. 8 plus 14 will give us 22. 22 here. Then we go for the last element. This column multiplies this column. So we have 2 times 3. 2 times 3 plus -7 times 5. So 2 times 3, 6 plus -35, and that will give us -29. So this is BA now. BA. So as we can see, AB is not equals to BA. So we call this non-commutativity of two matrices. So that does that for this one.